Hello students, welcome back. Now in this part I am going to tell you about differentiability by differentiation. So how to check whether a function is derivable or not by actual differentiation. This we will see in this part. So let's start with the video. Okay, so let us study about differentiability by differentiation. Okay, so now in this topic I am going to tell you how we can find out whether the function is differentiable or not by actually finding out dy by dx, right? By actually differentiating the function. Right, so here also we are going to find out what is LHD, RHD, but here in this case we are not going to use the concepts of limit, but we are going to use the concepts of dy by dx, or actually differentiating the function, right? So here you will get the feel of actually differentiating the function, right? So here let us solve the first question, right? In this there is no concept, right? I will take you through the concept through this question itself, right? So I have directly given you a question. So this question is, if fx is equal to x, if x is less than equal to 1, so this function is defined like this, right? X is if x is less than equal to 1, and x square plus bx plus c if x is greater than 1, right? Now in this question it is already given that fx is differentiable at x equal to 1, right? It's already given in the question that fx is differentiable at x equal to 1. So now what you have to do is you have to find out the values of b and c. Now what should be the values of b and c so that this function becomes differentiable? We have to find out that. Right, so let me try to give you an idea how to solve this type of questions, right? This type of questions are also much seen in IIT-JEE exams, right? In JEE Mains, JEE Advanced, both the exams. Okay, so if fx is equal to this, right? Now see, first of all tell me, remember the theorem that I told you, theorems on differentiation, right? If fx is derivable at x equal to 1, will it be continuous also? Right, this is the twist in the question, right? Because see, there are two variables, and there is only one information that is provided, that fx is differentiable at x equal to 1. So from this information we can derive only one equation, right? We can get only one equation, but there are two variables. So how to solve an equation with a two variable, right? It's not possible. So we need definitely one more equation, and from where will I get one more equation? If fx is derivable, it will be continuous also. If fx is derivable at x equal to 1, it will be continuous also at x equal to 1. Am I right? Because if a function is derivable, it has to be continuous, right? Theorem 1, the first part, right? So if this is fx, first of all, this function is continuous at x equal to 1. If this function is continuous at x equal to 1, can I say LHL is equal to RHL is equal to f of a is equal to finite? This is the definition of continuity, right? Here we are talking about the continuity at x equal to 1. So basically f of 1 minus should be equal to f of 1 plus should be equal to f of 1, and this should be equal to finite. And what is f of 1? See, f of 1 will be this definition, right? I will use this definition for x equal to 1. So f of 1 will be, in place of x I will just put 1. So f of 1 is 1, right? Now what is f of 1 minus? F of 1 minus is also 1. What will be f of 1 plus? F of 1 plus will be, I will put x equal to 1 in this definition. So if so f of 1 plus will be nothing but, I am writing down here, f of 1 plus will be 1 plus b plus c. So this is our equation number 1 that we are. So basically b plus c is equal to 0, right? From here, this is equation number 1. B plus c is equal to 0. Let me say this is equation number 1, right? After simplifying. Now the second condition I will get from here, that fx is differentiable also at x equal to 1, right? If fx is differentiable at x equal to 1, I can say that LHD will be equal to RHD will be equal to, this will be equal to finite, and we are talking about differentiation at x equal to 1. So what will be LHD? Left hand derivative will be nothing but f dash 1 minus, and right hand derivative will be nothing but f dash 1 plus, and this should be equal and it should be finite, right? Now let me differentiate the function. So if fx is given, right, this is fx. So if I differentiate, what will be f dash x? I can directly differentiate, right? This is the differentiability by differentiation. So I can directly differentiate these two functions. Okay, so what will be differentiation of x? It will be 1. What will be differentiation of this function? It will be 2x plus b, right? And this definition will be valid if x is less than equal to 1, and this definition will be valid if x is greater than 1, right? Now what will be f dash 1 minus? I will put x equal to 1 in this. So f dash 1 minus is 1. And what will be f dash 1 plus? Now for 1 plus I will put x equal to 1 in this definition. So this will be 2 plus b. So from here if I solve this equation, I will get b equal to 1 minus 2, which is equal to minus 1. So if b is equal to minus 1 from equation 1, what will be c? C will be equal to plus 1. So understood this problem, how we have to solve it? First I will use the condition for continuity, because if it is differentiable it will be continuous also. And second equation I will get from here that fx is differentiable at x equal to 1. So LHD equal to RHD equal to finite, and LHD RHD you can directly find out by directly differentiating the definition of the function. Okay, there is one more example. Now this example you should try it yourself first, right? It is exactly same type of question. So here fx is equal to sin x if x is less than pi, and m pi plus n if x is greater than pi, and it is given that mn, and for you to find the values of m and n if fx is derivable. Now if it is written fx is derivable, it is derivable at all the points, right? So if fx is derivable at all points, can I say fx is derivable at x equal to pi also? Yes, it is differentiable at x equal to pi, it is derivable at x equal to pi, right? So what will be the solution? If it is derivable at x equal to pi, can I say it is continuous also at x equal to pi? If it is derivable, it will be continuous at x equal to pi also. And if it is continuous at x equal to pi, I can say that f of pi minus will be equal to f of pi plus will be equal to the value of the function, which is f of pi, and this will be equal to finite. Now what is the value of f of pi? At x equal to pi I will use this definition, right? So what will be f of pi? F of pi will be nothing but, I think here this should be mx plus c. Okay, so make this changes. Okay, there is a printing mistake. So this will be mx plus n, right? Mx plus n. So what will be f of pi? F of pi will be nothing but m pi plus n. What will be f of pi plus? F of pi plus will also be same, because I will put x equal to pi in this definition, right? And f of pi minus, so here x is less than pi. If x is less than pi, I will use this definition. So put x equal to pi in this. If I put x equal to pi in this, I will get sin pi. And sin pi is nothing but 0. So first equation is m pi plus n is equal to 0. This is the first equation. M pi plus n equal to 0. Okay, this is the first equation that I have. And second equation I will get from this condition that fx is derivable at x equal to pi. If fx is derivable at x equal to pi, I can say that f dash pi minus will be equal to f dash pi plus, right? And this will be equal to finite. Okay, now let me differentiate this function. If fx is given, right, so what will be f dash x? If I differentiate this function, sin x will be cos x if x is less than pi, and if x is greater than equal to pi, then for this I will get mx plus n. So if I differentiate this, I will get just m, right? So what will be f dash pi minus? For pi minus I will use this definition, so this will be cos pi. Put pi in this definition, right? And now put pi in this definition, so this will be nothing but m. So m is nothing but minus 1, cos pi minus 1. So the value of m is minus 1. So what will be value of n? N will be minus of m pi, and minus of m pi is nothing but n equal to pi. So the value of pi, n is pi, right? So m equal to minus 1 and n equal to pi. These are the answers. Okay. Hello students. So I hope that differentiability by differentiation is clear to all of you. Now in our next part, which is again a very important part, we are going to see about previous year IIT-JEE questions. So stay tuned till then. Thank you. Goodbye.